Hello, and I'm back, Mr. Hine. And in this video, we're on the third part of curve analysis. And in this video, we're going to explore all those definitions I just went over through graphs where we can better understand all of this. Right? So this one video today, I'm going to cover this point here. We'll sketch f of x, f prime of x, the derivative, remember that that's the slope function of f of x, and then f double prime of x, which is the slope function of f prime of x. Right, or the rate of change of f of x, such that if f of x follows all these conditions, right? And off to the right here, I'm graphing f of x, the derivative f prime of x, and the second derivative f double prime of x. Okay. So let's make sense of this together, and hopefully as I go through this, you understand this. So f is continuous on negative infinity. That means that the whole graph will be connected. There won't be any jumps or holes in it. It has zeros at -4, so 1, 2, 3, -4. At -3 halves, so -1, -3 halves. At 2, and at 5. It has zeros. It has local maxima at -3, 4. 1, 2, 3, 1, 2, 3, 4. So that's a maximum. Maxima is just the plural version of maximum. And at 2, 0. 2, 0. So when I say max, that means that the graph will do something like this at those points. Okay. It has local minima, so just the plural version of minimum at 0, -2. So it's a minimum, so we'll have a curve like that. And at 4, -3. 1, 2, 3, 4, 1, 2, -3. Okay. It has points of inflection. Now remember that points of inflection is when the second derivative, when f double prime of x, changes sign. That's what a point of inflection is, right? And remember, when we're talking about concavity, so points of inflection has to deal with concavity, possibly, and concave up is it kind of looks like a bowl that holds water. Concave down is a bowl that doesn't hold water. And that's not a perfect example of it because you'll see, if you saw in the last video, it kind of stops midway sometimes as it's shifting from concave up to concave down. It has to have that middle point where it shifts over. So it's not the full bowl that's holding the water, a bowl that's losing water. But that gives you a visual of what it might look like on f of x. Right? So at -2, 3, -1, 2, up 1, 2, 3, it will have a point of inflection. At 1, -1, it'll have a point of inflection. At 3, -1, -2. I'm going to do these with x's. So at -2, 3, 1, 2, 1, 2, 3 has a point of inflection there. At 1, -1, 1, -1 has a point of inflection there. And at 3, -1 has a point of inflection there. And then f is increasing. Now remember, when f is increasing, that means that f prime of x is positive, and f is decreasing, f prime of x is negative. Similarly, I missed this, but when it's a maximum, that means that f prime of x went from a maximum means the slope is positive and then it's negative. So it goes from positive to negative. And a minimum is when the derivative of f of x goes from negative to positive. Okay. So if we keep going with this, f is increasing, so that means the slope is positive from -3, -3, -1, 2, 3. So up until this point, the slope's positive, which we could have guessed that because of our curve. It has a positive slope. It also has a positive slope from 0 to 2, 0 to 2, which makes sense. I connect where it had a local minimum to its local maximum. Then from 4 to infinity, 1, 2, 3, 4, is at that minimum, it has a positive slope. So we can see all that. F of x is decreasing, so the slope is negative from -3 to 0, 3 to 0. Make sure I go through that inflection point. It's just a sketch. And then from 2 to 4, so from 2 to 4, it also has a negative slope. And just like that, there's f of x fulfilling all those criteria. Right? Now, I'm going to challenge us and see, can we graph f prime of x, f double prime of x? So first thing on f prime of x is when are there zeros? Right? Now it had a maximum at -3, 4, and at 2, 0. So at -3, 2, 3, it had a 0. And at 2, it had a 0. And it also had zeros at 0 and at 4. And the way you might be asking, how did I get that from just these points? Remember that at a maximum minimum, the slope has to change from positive to negative. And as you slope changes from positive to negative or negative to positive, it's equal to 0 at one point. Right? Graphically, we can see at -3, the slope is going from positive, and then at 0 to negative. So it's going from positive to negative. So it would look something like that. At 0, the slope is going from negative to positive, something like that. At 2, it's going from positive back to negative. Remember, we're looking at positive to negative. And then at 4, it's going from negative to positive again. So a sketch of this graph would look something like so. And there is f prime of x. In which we can see that at the zeros -3, it's going from positive to negative. So at -3, it had a local maximum, which f of x did. So this right here, since it's going from positive to negative, f of x has a local max. At 0, it's going from negative to positive, so that's a local minimum, which we could see on the graph above it. If I can zoom in as much as I can to help you see what I'm writing. At 2, it's going from positive to negative, so that would be a local maximum, which we could see on the graph there, that there's a maximum right there, local. And at 4, it's going from negative to positive, which would be a local minimum, which we can see on the graph. At 4, it's a local minimum, and that's great. Now we move on to f double prime of x. Right? So we're looking at the slope of f prime of x, and we can see that the slope is changing from negative to positive at, well, it should be at negative maybe 2. And the reason I know that is because I'm looking at my point of inflection at -2. F double prime of x changes sign. So at -2, my slope, what should have happened here, I guess, is it should have done something like this. And then at 1, it has a point of inflection. And then f double prime of x has a point of inflection, or f of x, sorry, f of x has a point of inflection at 3, -1, which means that f double prime of x changed sign at 3, -1, so at 3, leave it. And we can see this when we look at f prime of x. And I know you might be getting lost in all these positive negatives, all these new vocab of which function am I on, f prime of x, f double prime of x. Remember that a lot of what we're doing, most of what we're doing relates back to f of x. We study the rate of change and the rate of the rate of change to understand the original function, typically. Right? So let's just make sure we understand that. So at -2, we can see that f prime of x is changing from negative to positive, negative to positive. At 1, it's changing from positive to negative. And then at 3, it's changing from negative to positive again. So you can see the graph would look something like this. And there's f double prime of x, right? In which at -2 is a point of inflection. Because f double prime of x is going from negative to positive, it's changing sign. At 1, there's a point of inflection there because it's going from positive to negative. And at 3, there's a point of inflection there because it's going from negative to positive. As for concavity, concave up and concave down, remember that concave up is when the second derivative is positive, So when is f of x concave up? Now this wasn't part of the problem. It's concave up from -2 to 1 and 3 to infinity. And when was this function, when was f of x concave up? When was f of x concave down? Remember, concavity relates back to f of x, right? But we use the second derivative to determine that. F of x was concave down when the second derivative is negative, which that's from -infinity to -2, and from 1 to 3. And let's relate this back to f of x and see what this looks like on f of x again. So f of x is concave up. So what we imagine is if it's concave up, it'll be some sort of upward bowl, right? So let's look. So back at f of x, see if I can get all this on the screen. At -2, from -2 to 1, so from -2, there's the x that I made, to 1, this whole part of f of x is concave up. And you can see that it's holding water, it has that upward bowl. And also from 3 to infinity, so from 3 to infinity, notice that it's also concave up there, in which it has that bowl that's holding water. And then similarly, if we were to check concave down was from -infinity to -2, which I'll do this in highlight. We're expecting it to be losing water, the function, in which we see that there. Notice how f of x is losing water. And then also from 1 to 3, which is there. So everything matches up. Okay? And there's a very nice example going through f of x, f prime of x, f del prime x, and a lot of the definitions and understanding how their meanings relate to the graph. All right, look it over, maybe try it yourself, see if you get the same thing I get, because you might be able to follow along with me, but if you have the time, see if you can do this. If you can do this and get the same results I got, you'll probably feel a little bit comfortable with it too. All right, good luck on it.